All right, some of these that you're going to do on your own. Mm-hmm. Inside the circle, write the degree measure of the angle theta, where theta is between 0 and 360. Okay, so like for example, it says it starts at 0, but it doesn't include 0. Okay, so that's not 0. It's not 0. All right. Right here, that would be 45 degrees. This is 30 degrees. This is 60 degrees. What's this one? 90 degrees, right?
Oh, so are you putting degrees and radians?
We're starting with just degrees. Yeah. So you finish the degrees all the way around, and then we'll fill it in together. Everyone who's not here is unsure, right?
Yeah, they were all here.
Boring to watch this video because there's a lot that you have to do, but you can't pause this one. You know, like when you do it on the smartboard, you can pause it and come back to it. This one doesn't pause. You just have to keep watching it forever. All right, so what's this measure right here? You know?
120.
That's 120, and this is,
135.
yeah, and this one?
50.
150, and this one? 180.
So is that one on the opposite side 0?
No, because see, 0 is not included, but 360 is. So this is 225, 240, 270, 300, 315, 30, and 360. Okay. Notice every angle on this unit circle is a multiple of either 45 degrees or 30 degrees. So now let's convert 45 degrees and 30 degrees into radian measures. So 45 times pi over 180 degrees. 45 goes into 184 times, so that's pi over 4 radians. What's the other one? 30 times pi over 180 degrees. That goes 6 times, so that's pi over 6 radians. So now we're going to write the radian measure of each angle theta, starting at 0 but not including 0 and going all the way into 2 pi. So we know what this one is. This one's pi over 6. And then see, 60 would be 2 pi over 6, except it actually reduces to pi over 3. And then this would be 3 pi over 6's, but we're going to write it as pi over 2. I'm going to let you finish the radians. And then we'll talk about it. A little coffee talk.
You smoke like 7 times a day.
Since birth.
Yeah.
Since birth.
Since birth.
Speaking of coffee, so I'll get a flash on coffee cup. While you do your radiance. Talk amongst yourselves. I'll give you a topic. Radiance. Go.
Hi.
Around with radiation. Let's talk about those atomic bombs that we dropped.
Segway.
H-bomb's 1,000 times stronger than the ones dropped in Nagasaki.
The heck bomb.
I gotta see if Alex from that video.
You did?
I gotta see if he did.
That's a gold mine.
I heard that over the years. What is pi, right? Is it? That's what I thought. And 360 is 2. I'm assuming.
Are we done?
Yeah, way there.
Halfway? Okay.
Yeah, it's bottom half.
Yeah, so
I thought you were snapping me. I was like,
get home with it.
All right, let's finish filling this in. So 120 should be 2 pi over 3. 150 is 5 pi over 6. 180 is pi. 210,
what about 135?
I'm going to go back and do all the 45s.
Oh.
See, I'm just doing the multiples of 30.
Yeah.
And then I'll go back and do the multiple, which you gotta have it all filled in. It's just that we were kind of going by adding pi over 3 every time. I mean, pi over 6 every time. So that's why I went through and did these. All right, so this is 7 pi over 6. And this one is 4 pi over 3. 270 is 3 pi over 2. 300 is 5 pi over 3. Then you have 11 pi over 6, or just 11, because I forgot to write the pi. 11 pi over 6, and then this is 2 pi. Now for the 45s, that one was pi over 4. And this one, you could say, well, that's 2 pi over 4, which it reduces to pi over 2. Same thing, right? Over here, you get 3 pi over 4. Right here, you get 5 pi over 4. And then right here, 7 pi over 4. And you're all filled in, right? Okay.
I mean, in theory, you only have to know one or the other.
Right. And that's what you're going to learn, that there's sort of a pattern here. You'll get the pattern. Now, this is going to be a little bit different. Now go through and write your radian measures on the inside. Okay? So, like, this is pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. And this one is 2 pi over 3. I'm just copying them from the other page.
Could you zoom in on anything?
I'm not sure you want me to, because I just... Oh, you know what? I don't think I can when I'm recording. I don't think it'll zoom. I just have to, like, physically move it closer, which makes it kind of distorted. But that's all you get. So you're just copying these from the other side, that's all. This is what you just did on the other side. These are your radian measures. Okay. Now, at this point, we want to know what these actual coordinates on the unit circle are. See these right here? These are coordinates. Okay? Like with an x value and a y value. So now we're going to try and find out what they are. We're going to use the definition of the unit circle, and we're going to use our special right triangles. Okay? So I'm just going to draw like a quarter of the unit circle right here. If this is the unit circle, what's this point right here? No. The coordinate. It's 1, 0. Okay, this is the coordinate 1, 0, right? What's this coordinate right here?
0, 1.
0, 1. All right. Now, let's start off with kind of easy one. That's 45 degrees. If I bring my reference angle down, that's also 45 degrees. This has a length of 1, right? Yeah? Because that's the radius of the circle. What's the length of this side and this side? Because it's the same length. I did it on purpose. I made it 45, 45, 90 on purpose. What's the length of these two sides? Do you remember your 45, 45, 90 rule?
Oh, yeah.
Square root of 2.
Okay. You're close. It does have to do with the square root of 2. Remember your 45, 45, 90 triangle. If this is x and this is x times the square root of 2. Okay, so that means 1 times something has to equal, or this 1 equals something times the square root of 2. So you divide by the square root of 2, and you get that x equals 1 over the square root of 2, or, because you got to rationalize your denominator, it's the square root of 2 over 2. So that means this length right here is the square root of 2 over 2, and this length right here is the square root of 2 over 2. right? So right here, what's the coordinate of this point right here? How far did I go over to get to this point? Square root of 2 over 2. How far did I go up to get to that point? No,
Square root of 2.
square root of 2 over 2. Okay, this angle right here,
It's gonna be the same thing, but a sign's gonna be different.
exactly, it's going to be the same, but a sign's different. Which sign is different?
The X,
Yeah, it's going to be a negative square root of 2 over 2 and a positive square root of 2 over 2. Which other one, what's another one that's the same, just with different signs?
power.
Yeah, right here. Both of them are negative, right?
Mean 7 power.
Okay, what is it going to be for 7 pi over 4?
The first one's gonna be positive and the second one's gonna be negative.
Yes. All right, awesome. All right, let's do this 30 degree right here.
Is it gonna
Can
be
you speak down your
30,
paper?
60,
Oh, sorry. I forgot I shoved it way down. It's a 30, 60, 90. If this is 30, that's 90, because I've got the unit circle going here again. I didn't draw it in, but I got a unit circle here, okay? So that's 1. That's 30. That's 60. So I'm looking for x, y. So this is x, and that's y. Do you remember your rules for your 30, 60, 90?
Square root of 3 involved.
There is a square root of 3 involved, yeah. The short side is A. That's the one that's across from the 30.
The
The-
hypotenuse is 2A, right?
Okay, so the one across from the 90 is 2A. The one across from the 60 is A times the square root of 3. All right, so this is the one that I know right here. I know that 1 is equal to 2A.
So A has to be 1/2.
So A has to be 1/2. In this case, is A the X or the Y?
The X. Right?
What's a, it's the Y, okay, so I know it's up here, it's gonna be comma 1/2, right? That's what it's gonna be. Now, the side that's across from the 60, which in this case is the X, is A times the square root of 3. So that's just the square root of 3 over 2. Okay, so I got that going on. Okay, let me ask you a question. What's going to happen when I move from this 30 degrees to this 60 degrees?
Multiply it by. You're gonna.
Are the values actually going to change, or
They're just gonna flip.
they're just going to flip? Right. Because remember, what was opposite to one is now adjacent to the other.
And then are you just gonna change signs when you go?
Now you're just going to change signs. So what is this one going to be?
-1/2 square root of 3 over 2.
Yep. And what's this one going to be?
Negative square root of 3 over 2, 1/2.
Yes. And this little fella right here?
They're both gonna be negative. It's gonna be negative 3, the square root of 3 over 2, 1/2.
And the negative 1/2, yeah. And this one, they're both negative, and it's negative 1/2, square root of 2. It's all about those reference angles. You're always thinking about your reference angles. How about this one? What's this one going to be?
1/2 negative 3 over 3 square root over 2. Or the square root of 3 over 2.
I knew what you meant.
Yeah.
There were a lot of numbers there, but I picked them out. So this guy right here,
Square root of 3 over 2, negative 1/2.
right. So then the only ones we have left are the biggies. What's this guy right here?
Just one.
1, 0. And this guy,
0, 1.
0, 1. And this fella,
3 of 1, 0.
uh-huh. And right here?
0, 1.
I like those.
Yeah, those are my favorites. Okay. Let's keep trucking. Let's keep rolling. Rolling, rolling, rolling. So now we're going to redefine these 6 trig ratios in terms of our circular angle trig, okay? So sine of theta. This is going to be theta right here. That's theta. So sine is opposite over hypotenuse, right?
That's gonna be y over a.
Y over r.
Yeah.
Cosine is adjacent over hypotenuse. So that's going to be, cosine of theta now would be, I'm going to put sine of theta just so we know what we're talking about. This is far away. What's cosine? If it's adjacent,
It'll be x.
x over r. Tangent is opposite over adjacent. So what's the tangent of theta here?
Over X.
I'm sorry, I didn't hear.
Y over X.
Y over x. Yes. All right, so cosecant, remember, is the reciprocal of sine. So cosecant is hypotenuse over opposite. So in this case, the cosecant of theta would be
R over y.
r over y. Secant is the opposite, not the opposite, is the reciprocal of cosine. So that's hypotenuse over adjacent. So that's going to be, the secant of theta would be r over x. And cotangent is the reciprocal of tangent. So that's adjacent over opposite. So the cotangent of theta would be x over y. Now, using the unit circle that we just came up with, let's see if we can find the sine of 3 pi over 4. The sine is going to be y over r. So where's 3 pi over 4? There it is. Y is the square root of 2 over 2 over 1. So that means it's the square root of 2 over 2.
Wait. How did you get over 1?
Because it's over r, and it's a unit circle, and the whole point of the unit circle is that r is 1. That's why we call it a unit, because it's only 1. All right, the cosine of 3 pi over 4. All right, so the cosine of 3 pi over 4 is a negative square root of 2 over 2. Does anybody care if I don't write it over 1? Because it doesn't change it. And that's a tiny little box where I have to put all my work, and I'm not going to have room. Okay, so, yes. Oh my gosh, I love it. You guys, this is what we got instead of prom glasses. Isn't that awesome? Let me show this to the people at home. See what you're missing? We got these instead of, I don't even know those people, but they're really happy about this. It's a keychain that you can put a picture in, and then a picture frame with the little clippy clip. And we only ordered, what, like 35 of these, I think?
I have no idea.
I think so. So if you want one, you need to get your money in, because the first 35, will you ask her how many we got?
Are they the same price as the glasses?
Mm-hmm. Yeah, well, you got these two things, and because the glasses are kind of useless. Okay? Like, don't drink and drive. Have a beer stein, okay? Have a champagne glass. But don't get alcohol, because you're underage. But anyway, I like those much better. Super pumped about that. Yeah. A picture frame and a keychain picture frame. Instead of a glass that goes on your shelf. that you'll break eventually. All right, now back to this. So I have that plus the sine of 7 pi over 4. So 7 pi over 4. And is sine x or is sine y?
Why?
Y. Okay, so that's a negative square root of 2 over 2 again. So I have a negative 2 square root of 2 over 2. And I'm left with just a negative square root of 2.
I forgot we were adding fractions for a second.
Mm-hmm.
About that business.
I hate fractions.
All right, tangent of pi over 6. Okay, so remember, tangent is y over x. There's going to be some fraction division this time. So pi over 6 in the y place is 1/2 divided by the x, which is square root of 3 over 2. Do you remember how to divide fractions?
And like you flip one.
Yeah, you flip the bottom, flip and multiply. Like Napoleon Dynamite. Flip and multiply. Those cancel. I have 1 over the square root of 3. You can rationalize it. And you get the square root of 3 over 3. For right now, if you could get just to right there, I'd be happy. But eventually, you're going to have to get there. Okay.
Wait.
Yeah.
We're doing it, but it's like you take what's on bottom and you multiply it
Yes.
on top and bottom. Okay.
Because that like cancels the square root.
Yeah.
All right. Tangent of 7 pi over 6. I'm going to let you tell me what to write this time.
Negative 1
Negative
half
1
divided
half
by negative root 3 over 2.
Is that going to end up any different than the last answer?
No.
Mm-mm. No, because even with those negatives, they're going to cancel out. And that's going to be my answer. All right, how about the secant of 11 pi over 6?
1 over 1 over the square root of 2 over 2? No, square root of 3 over 2.
Yeah.
I read the wrong one.
So you flip and multiply, and it ends up being 2 over the square root of 3. And again, if you could just get to that point, that would be great. But your actual answer is 2 times the square root of 3 over 3.
So it's 2 over the square root of 3, or 1?
2 square root of 3 over 3.
We're gonna memorize this unit circle.
Uh-huh. You will, trust me. I mean, even if you don't mean to, you accidentally will. What about this one? What about the cosecant of 4 pi over 2? What is 4 pi over 2?
So just 2 pi.
It's 2 pi. So if you're looking for the cosecant of that,
So it's 1 over 2 pi.
no, it's 1 over 0. Is that a thing?
No.
No. So this one is undefined because 1 over 0. You have that 1 over 0. So this is undefined. Some of these, they're undefined. You can't have it. All right. What about a negative? What should I do with a negative? Negative 2 pi over 3.
That's a good question.
Do you take the inverse?
I thought you couldn't take the negative, like the sign of the negative. Or was that the inverse sign? So you can't take
Well,
the negative?
this is not asking me to take the sign of a negative. It's asking me if I start here and go in this direction 2 pi over 3.
So you'd use 4 pi over 3.
Why would I use 4 pi over 3?
Because it'd be like, it'd go in the negative
Okay. You're right, it's 4 pi over 3.
I know what he means.
Yeah, I think I understand what you mean, but, because you're right, and I'm with you on that, yeah. So I'm actually looking for the sine of 4 pi over 3, because those are reference
I was
angles.
about to say, do they have like the same reference?
Mhm.
Is that right?
Yeah. So what is the sine of 4 pi over 3? I know it's negative.
Negative square root of 3 over 2
Mm-hmm.
over 1.
Yeah, but we don't have to do the over 1. What is the tangent of negative 5 pi over 2? Hmm? Well, it's more than a circle, so you've got to figure out a reference angle.
Would it be 3 pi over 2?
Mm-hmm. It's 3 pi over 2, so you're looking for the tangent of 3 pi over 2.
So it's undefined.
It is undefined, right. Now, could I find a cotangent of 3 pi over 2?
Yeah.
Yeah, it'd be 0. But tangent is undefined. All right, let's look at this one. Really, I just want to look at this part of it because people get crazy with this right here. All this means is find this cosine, which you're going to be finding the cosine of pi, and then whatever the cosine of pi is, multiply it times negative 2. That's it. So don't lose your mind on that, okay? That's all you have to do on stuff like that.
So
What's negative 3 pi?
negative 1 over 1, which would make it negative 1 times 2.
Yeah. Is it 2 or negative 2?
I need to just sit down and look at it for a good like 20 minutes and then.
You've got to be able to do those reference angles. Because what you have to do, negative 3 pi, if I add 2 pi, that's not enough. So if I add 4 pi, that puts me at a positive pi.
Right.
So that's what you're looking at.
Okay.
All right, let's look at the next page.
Oh, I got you. So you're starting 2 pi.
Mm-hmm. Until you get a positive answer. Yeah. Yep. Okay, describe below are angles in standard position. Determine which quadrant or on what axis each angle terminates, and give an explanation that clearly justifies your reasoning. If no such angle exists, explain why. So where is there an angle that the cosine is greater than 0, but the tangent is less than 0?
Where did it go? I think it just went over my head.
Okay, so the cosine is greater than 0, so that means the cosine's what? What's the sign for that? What sign is greater than 0?
You know, positive.
Positive, yes. Okay.
Oh, I was like, what?
All right, where is cosine positive? In quadrant 1 and where else? 4? Okay, so quadrant 1 and quadrant 4. Because remember, cosine, your x determines your cosine. So that's 1 and 4. But then it says tangent has to be less than 0. So what kind of number is less than 0? A negative. And if I'm looking at tangent being y over x, then one of those has to be positive and one of them has to be negative. Well, we've already said it has to come from 1 or 4. So where does it have to be? It has to come from 4. It has to come from 4 because cosine has to be positive, but tangent has to be negative, which means the sign would have to be negative.
Right.
Okay? You can kind of sketch something down real quick just to remember that, but let's talk about it some more. All right, let's look at the next one. Okay, the next one says that cosine is greater than 0. So we've already talked about that. Where is that happening? Quadrant 1 or quadrant 4. Anywhere in that area, okay? And tangent is undefined. Well, we've talked about this. When is tangent undefined?
X is 0.
When x is 0. Because, see, tangent is y over x. That only happens at pi over 2 and at 3 pi over 2. But it said that the cosine has to be greater than 0. So can x be 0 and greater than 0 at the same time? No, this one doesn't exist. That one does not exist. All right, try C. Try to talk and think your way through C without me doing it with you. Like, try to do that one. And then we'll do it, but we will talk about it, but you try to do it first.
Yeah, so for positive, it has to be B. If that's Y over, yeah, so it has to be that way.
So that's what's important too. Because
But what's the hypotenuse over opposite? And it's less than? So it has to be down here, right? Is that a quadrant or is that just an axis? Or on what axis? I think we don't have to write down what it is, we just know what it is.
Yep, we're going to talk about it.
Oh.
I mean, if you write down something you can remember.
Yeah, it's that one, right? Because one has to be negative, one has to be positive. Yeah. Wait, but it can't be 0, so no, I have to think of it. The quadrant?
Did you have quadrant here?
I thought you were saying.
Well, tangent has to be x over y.
All right, so what do you think? Tangent
Y
has to be
over
greater
X.
than 0. Cosecant has
Y
to be
over
less
X.
than 0.
Say one.
Y over x. Right.
Is it 3?
It's 3. Why is it 3?
I got them backwards.
Because,
If tangent has to be greater than 0, they both have to be what?
negative.
Or they both have to be positive. They have to be the same sign, okay? But then the cosecant has to be negative, and cosecant is the reciprocal of what?
Sine.
Sine, so sine has to be negative. So that would limit you to quadrant 3. All right. Okay, let's skip down really quickly into this last one. Suppose that theta falls between pi over 2 and 3 pi over 2. And the sine of theta is 1/2. What is the value of theta? What falls between pi over 2 and 3 pi over 2 that has a sine of 1/2? Pi over 2, 3 pi over 2. It has a sine of 1/2. What sine, x or y?
One.
So
Five
5 over
5 pi over 6. Yeah. So theta is 5 pi over 6. And then it wants the other 5 trig ratios. Okay, well, cosine's easy. Cosine of theta would be negative 3 square root of 2. Oh, negative square root of 3 over 2. Secant of theta would just flip the cosine. a negative 2 over the square root of 3. Cosecant,
Can you scoot your paper up a little bit?
oh yeah, cosecant would just flip the sign, which is 2. I guess I don't have to write theta. I know what it is now. It's 5 pi over 6. What about tangent? We might have to do some math on this one. What's a tangent of 5 pi over 6? We're looking at 1/2 over a negative square root of 3 over 2. So if you flip that, you're looking at 1 over the square root of 3. I'll let you leave it like that. So if tangent is 1 over square root of 3, what's the cotangent? Oh, it's negative. It's negative, sorry.
Or negative, oh, sorry.
Yeah, negative square root of 3 over 1, which you don't have to write. 1, 2, 3, 4, 5. There's our 5 other trig values. Look at this. You got some day 66 over this nice 3-day weekend. 14 problems? Is that right? Yes.
I'm gonna have to rewatch this.
I'm just gonna.
Good luck, people watching.
Good luck, all of you at home. I hope you know each other's phone numbers. You're going to want to call somebody. Phone a friend.
Mostly promotional